Happy April to all of you. We've made it to another month. Can you believe graduation's gonna be next month? How that will work out, I don't know. But one way or another, seniors, you are going to graduate. So don't worry about that. Unless you're not participating in my class. There are some of you who are not at this point. That might keep you from graduation more than this virus will. So if you have not logged in yet and you have not submitted any homework, start now. We're early in the quarter. But I am worried about some of you if you don't get your work into me and your other teachers. But right now, I'm the only one that I know about. Okay, so what we're going to talk about today is what happens when you have a charged particle. So when we have any sort of mass, let's see, if I remember correctly, I was super excited about drawing on the screen. I forgot this one won't let me. We'll make it as big as I possibly can. Perfect. And then use this app I've got over here. Okay, so when I had any sort of mass, objects were going to be drawn towards its center. One thing we did not talk about in my class, but if you've had Ramsey, he has mentioned this in some of his classes I know, is this idea of any mass distorts space-time. That's something I'm going to talk about a little bit when we do our special relativity, but I don't do a full section on it right here. But the whole idea that maybe you have something that was traveling in this direction, but the mass of the planet that you see pulls it in and changes its path slightly. Getting into some sophisticated ideas with physics that I'm not going to stress right now. But turns out that that way that masses would pull, say, a comet into its orbit so it doesn't continue in a fully straight path explains what's going on with our charged particles as well. Now, we've talked before, you can have two types of charged particles. You can have a positive charge and you can have a negative charge. And of course, when we talk about positive charge, we're saying this has more protons. This one has more electrons, leading to an overall positive or overall negative charge. So as I look at this, there is a convention that is used widely in physics, and that is this convention of electric field. What happens is, if we were to put any other charged particles around these fixed particles, the new charge that I place would move according to these lines that I see here. The lines describe how my field distorts the path of a new free-moving particle that's placed in its proximity. Free to move. So, which direction it moves does depend on whether your free particle is of positive or negative charge. Of course, if it is a negatively charged particle, it's going to be most attracted to our positive charge right here. If it's a positive charged particle, it's going to be most attracted to our negative charge right here. But because, I think it's probably because what we usually shoot between these charged particles are typically positive particles, the convention that was created showed these field lines always with the arrows coming out of the positive particle and coming into the negative particle. Whether or not that's where it actually will move will depend on if this particle here is positive or negative, but in the real experiments where they run this, it's usually a proton, or it's very often a proton that is being used. It's being put in proximity of other charged particles. So it does usually follow these paths. What I have here, this is something I've never seen, or you've never seen before, is all of these arrows put together create what's called a vector field. When you go into some higher mathematic classes, it might be something that you're going to see, just depending on which classes you take. It's mostly used in physics-based classes. But when I have a vector field, the whole idea is I know how this particle is going to move based on where it is compared to the other particles. So let's say that I place a charged particle right here. I can expect, and again, I am going to assume this is a positive particle. I can expect it's going to follow the path of this arrow, and then probably this arrow, and then this arrow, and then this arrow, and then this arrow. And it's going to have probably a path that looks about like this. Let's say instead I put the particle right here. And again, I'm going to assume positive particles for everything I'm doing today. I see the path, the arrows that it's closest to. I expect that this particle will shoot off in this direction when it's given the opportunity to move. If I were to put it right here, I expect it's probably going to follow a path something like this. If I put it here, it's going to follow a path about like that. So all of these just indicate how my particle will travel. So your homework that's going to be assigned with this part, and I am assigning 2 homeworks today, is going to be pretty simple. You're going to open up this interactive, you're going to go to this worksheet, and you're just going to draw in the vector fields that happen based on the diagrams that it asks you for. Here you see you might have more than one particle. Let's actually go to full screen this time. You can add as many of these particles as you want or need for the situation. But just diagram out what the vector field looks like. That's the first part of your homework. It's super, super easy. The second part of your homework, there are some of you that already did this. Even if you submitted this assignment and you told me how many levels you played, I do want you to take some more time with it. This electrical field hockey is just you trying to manipulate your charge so it goes into a goal. You're going to add charges to try to influence it. So for example, if I put one right here, this is not going to be a great idea because this is a positive charge, this is a positive charge. If I hit go, they repel each other. But if I put, say, a negative charge in, you can see it's being attracted to the negative charge. I hit go, it's going to start off in that path, and it isn't necessarily going to stop here. As you can see, it went right through it, but it is being most attracted to that point, so it's kind of like having a mass on a spring. I've never had it bounce quite the way it is right now. Let's reset the charge. If I put it in closer, usually I can get it to go in when I do that. Well, let's put it right there. It's going to influence the charge, and you're going to try to create a path that's going to get it to go into the goal. There are 9 levels. I do want you to try all of them. You can add as many particles as you would like to this, whatever you want to create. But yeah, have fun with it. I want you to play with this because this activity is one of the best to see how the particles would move when they're under the influence of some fixed charge particles on the screen. After today, what we are going to do is we're going to move into circuitry and some basic ideas of electricity as it's used in everyday life. And then that section will last us about a week and a half, I'm guesstimating. And then we probably will be ready for our next test. So just kind of a heads up there. Your test will be obviously over the internet since we are not going to be meeting in person. But we can arrange, I'll explain that to you when we get closer to that. Anyway, I hope you have a fantastic day, whether this is Wednesday, Thursday, Friday, Saturday, or Sunday, or even Monday that you're watching this. Just make sure it's all in to me by Monday. And if you get bored, let me know, and I will come up with some more things for you to work on. And I hope you guys are all having a great day. If you guys do have questions, one thing I do want to stress is every single school day from 11 a.m. to 1 p.m., I am sitting at my computer. I've got the Canvas conference open where we can face chat with each other, or FaceTime, however you want to call it. If you go to your Canvas page for my class and look at the left-hand side of the screen, here I'll show you, in fact. So here's your class. Over here, where it has all of these different tabs, this conferences. If you go here, I have office hours that I'm leaving this open, but if you go in any time that's not between 11 and 1, I'm probably not in there. But between 11 a.m. and 1 p.m. every class period, every school day, I'm inside this conference and just waiting for you if you have any questions. So let me know. I am trying to go pretty easy on you while I get used to this whole distance learning. But we'll see how this goes. Anyway, I hope you're having a great day. I will chat with you more later, and if you need anything, please reach out and let me know.